Welcome back. This is Herpetological Highlights. It is episode 230, I do believe. I'm Ben Marshall, and co-hosting, as always, is Tom Major. And I think we have a little bit of a confession, because we've got a paper here that we're kicking off the episode with, which, strictly speaking, doesn't focus on those things that crawl upon the ground. Those herps. It's kind of actually really a paper about a species of bat.
It is a bat. This is a bat paper. Frogs are the victims in this paper. They're considered as little more than just prey to be taken advantage of. But
a very interesting prey that behave sort of in a diverse way, which sort of modifies their vulnerability to depredation by bats.
Yeah, so you've got this situation where these bats killing and eating frogs, and there's a little bit of decision making going on. So I'll just quickly introduce the paper. It's by James, Mara, Touchon, Ryan, Bernal, and Page, 2025, The Ontogeny of Decision Making in an Eavesdropping Predator, Proceedings of the Royal Academy B. That's such a classic Prop B title. I love it. So
ontogeny then.
Ontogeny of decision making, ontogeny. So ontogeny, where it's things that change as we age. Can you give me an example of something which has changed in our ontogeny, Ben, since we've been babies?
Height.
Height, good one. Yeah, height. Also the size of your
preference, head. Like olives.
The size of your head relative to your body. If it was still the same as when you were a baby, you'd be a freak. I wouldn't come near you, mate. It would be gross. So lots of things change as we age. Physically we change, but also we have the capacity to learn. Our behaviors change, and that's kind of what this paper's about here. We're talking about this bat. Now, I'm going to confess, I don't know anything about bats. I could probably name 10 or 12 bat species, the common ones that have been in films or that are sort of local to me. 12
bat species. Gosh.
How many bat species you got in the Rolodex?
See, I think I reckon I could place sort of, I know that there's a species that there's X, Y, and Z here, and I think it's probably called something like this. But like to the specifics of species, I don't know. I feel like 12 is probably a decent shout. I reckon there's probably a lot more that you're like, yeah, but I know that this bat exists. I don't know what it's called.
Yeah, vampire bat's a good one. Everyone knows about that one.
Right, but I don't think that's a single species.
No, it's not. It's probably about 15, isn't it? Yeah.
Right. So do you actually know 15 species because you said vampire bat? See, I don't think that counts.
No, I think it counts as one. You got to hedge your bets when you just go common vampire.
Right. Lesser vampire bat. Job done.
Lesser. Yeah. Or the bloodthirsty vampire bat. That'd be a good one. So, we're talking about fringe-lipped bats, Trachops cirrhosus. Scientific name cirrhosus is cool. It means curled or bearing tendrils, and that refers to the wart-like bumps on its lips and muzzle. I don't know if you took the time to Google this animal and look at its face.
I did.
Very strange face. Yeah, bats, it's always worth having a look at the face because their faces are so strange.
Oh, it's so diverse. So unique.
But this one's got little warts and bumps all over its face. It looks weird. It looks like, why is your face like that? It's like a sort of... like a pegboard of warty lumps. Almost like a... Very strange.
But I think...
But anyway...
Critically, big ears.
Crucially, massive ears, yeah. And that's because they're eavesdropping predators. So what does that mean? And this is actually the first time we've talked about eavesdropping predators on the podcast. I guess there aren't many reptiles...
It's not.
Amphibians known.
I'm gonna refute that because we have brought up... I am positive we have brought up eavesdropping predators in... I think in the realm of birds before at some point as a sort of side tangent for something else.
Okay, I'll take your word for it.
I think it was like sort of frog calling frequencies or something.
Okay, I think your memory banks are marginally more efficient than mine, so I'll take your word for it.
It was an aside. I can distinctly remember an aside. It might be a completely fabricated memory, but it's there.
Yeah, well, it's okay. Eavesdropping predation, though, is where they're listening in for a signal which isn't meant for them, but they intercept it and then they use that to kill and eat you. And in this case, the signal is the mating call of various different amphibians. The bats hear this mating call and they immediately know, okay, well, there's something delicious down there making that noise. I'm going to go and eat it. And Yeah, fringe-lipped bats, they're these sort of generalist eavesdropping predators, which is what makes them quite cool. A lot of eavesdropping predators apparently are very attuned to a specific call of a specific animal, and they use that to hunt them. But these ones...
Well, and you get... I think bats, you've got some wonderful examples of this, what people sort of refer to as arms races, right? You've got ones that use sounds made by moths to locate the moths and consume them, but the moths themselves have mechanisms to jam, essentially, the bat's ability to do so and to track them. So I think there is very tightly woven competition in some areas of bat eavesdropping, I think.
Yeah, I'm sure that there must be quite a big pressure on some of these frogs that they keep getting eaten by bats. So you'd think the calls would sort of shift over time, maybe to frequencies the bats are less capable of hearing or whatever it might be.
Or at different times, or you get better at hiding in bat-proof areas when you call or something along those lines, hiding in pipes. I don't know.
I see why frogs like pipes so much. This, obviously, the fact that they eat a variety of different things makes them interesting, and it's kind of what brought this study, because it means you can test how they respond to lots of different calls, and that's what they are interested in. They want to see if they behave differently based on the call of the amphibian they're hearing. So they had a bunch of amphibians, sort of varying from very delicious and palatable to the bats to completely unpalatable, and they wanted to see...
Yeah, 15 species.
15 calls, 15 species they were playing the calls of. And they wanted to see how these adult and juvenile bats responded to hearing these calls, and whether they were excited by them or whether they were sort of a little bit nonplussed. And the way they did that was they literally just played them the music. They put them in a booth and they played them the tunes.
They did. So all these frog calls are quite diverse. We haven't mentioned these are all sort of Panamanian frog species. This is where the whole study sort of focused. Is this area in Panama, and frog calls are obviously very diverse. So there were steps taken to try and standardize them, because what you want to do is sort of account for, maybe the recordings are different sort of length or loudness or anything along those lines. So you want to sort of standardize that as much as possible. So you're really getting at what the bat's hearing between different tests, between these different species, is something to do with the actual call characteristics itself, not a artifact of how you recorded it or something along those lines. So there were some controls to make it a bit more comparable, I suppose.
Exactly. And so they wanted to see whether or not the adults and the juveniles behaved differently, and they were playing them these calls, and the way they reacted to the calls was pretty cool, I thought. Did you see the video of where the bat, it hears, they had some supplementary videos, and when the bat hears a call of a delicious amphibian, it's so funny. It's because they've got massive comical ears, and when a dog is if you're trying to tell a dog something, but it's can't speak English, it's doing that thing where it's turning its head, it's kind of like that, but
yeah, upside down.
Yeah, upside down and way more intense, really looking around. There's something a little bit sinister about it, honestly. Yeah, and these bats get very excited.
The speed of the movement and the clear sort of laser focus, identifying where this sound is coming from, it does.
Yeah.
I mean, it is predatory behavior, right? They're getting ready to enact violence upon this frog. So no wonder it's got a little bit of intimidation when you see that movement. I think
it intimidates me. If these things were way bigger, they'd be awful. But they sort of they get really animated. They get really fired up. They look around real fast. Their ears are switching all different directions. And then they start flapping their wings. And eventually they take flight. And the ultimate is if they attack the speaker, that's when they're okay, well.
Yeah, so they did class... What was it? Interest, I suppose, was I think the term they used, ranging from head tilt and sort of looking in the direction all the way up to taking flight with that goal in mind. So you've got a metric of interest that is determined by the amount of sort of activity that the bat is demonstrating during the recording.
Yeah. And the big question here was, do they respond differently? Because not all of these amphibians are delicious to them, right? They've got a whole host of different ones,
right?
From a gradient of scale in big to small. We got lots of different frogs. We got a few different toads, including some whopping toads, which are very toxic. One of which being the cane toad.
Classic.
Yeah, and so they wanted to see essentially if, first of all, do the bats respond differently to the different calls, and then secondly, do the juveniles and adults respond differently? And if they did, that would suggest that maybe the adults were learning something with age that the juveniles...
There's some sort of process. Yeah, there's a shift. Just to touch on what they call palatability, you hit on the toxicity and the size, and sort of suggesting that they go hand in hand with some of the larger toads. There is a species which needs to be highlighted, which is big but not toxic, And that's sort of an unpalatable species of Leptodactylus. How would you say that? Savagei?
Savagei, because it's named after Savage.
And they highlight in this that frog is large enough that it will opportunistically take fringe-lipped bats, or at least bats.
Yeah, man. They're like basketballs, those things. They're crazy. Yeah.
So like, that's not palatable. Imagine you hear a frog call, you're like, oh, brilliant. I've got a great meal. It sounds big too. You swoop down. Next thing you know, you're the one being eaten by this behemoth of a frog.
And it has happened for sure.
That's got to be the least palatable frog there is. One that can fight back and eat you.
Is that the inverse of palatability, where it's like you've actually gone negative palatable because you yourself
you're palatable now. Yeah.
Really turned the palatable tables.
Oh, imagine the shock being a small juvenile bat swooping down. Next thing you know, frog tongue coming at you. Poof.
Yeah. Well, this is it. And it's a good point that you raise about the size. So one thing which was quite cool was that size, because we've had this before where things which are bigger tend to make deeper, longer sounds.
Right, they have some sort of, there's a tonality or timbre that comes with mass. Yeah.
And so it's like, whoa, I'm big. And so what the authors of this paper noticed was that generally the adults would have a preference where they would select frogs which were bigger, but only if they were palatable. So like, they know they're palatable, it's a frog I can eat, and it's bigger, they'd preferentially go towards that strongly. But with the juveniles, they didn't have the nuance to know whether or not the amphibian was palatable. They just knew it was bigger or smaller. And so what they found with the juveniles was that they had this same signature of like looking for the biggest frogs, but they didn't have the nuance to know which ones were palatable or not. So they were ending up flying towards things like cane toads, which are just poisonous, probably those Dactylus, which are just monstrous.
Yeah.
And so they don't really have that kind of learned nuance in their repertoire. And similarly, generally the adults, they would sort of much more in tune to what was palatable and what wasn't. Juveniles also showed low predatory responses to some of the really palatable species that adults liked, specifically complex calls of the Tungara frog. And there was another frog called the Smiliska Sela, which is a tree frog which calls in the dry season. And although they're palatable, the juveniles didn't really seem interested in them, maybe because they're more complex and they haven't yet learnt what they mean.
Yeah, so we've got these two angles, right? One is becoming more efficient at maybe IDing and learning that these maybe more ambiguous calls are actually a really good source of food. And then the other side is also avoiding the ones that are almost certainly not a good source of food due to size or toxicity. On the toxicity note, they do mention in the discussion that the way bats go after frogs means that they're not instantly going to get a lethal dose of any toxin. So basically they do have this opportunity to learn. They're not just instantly getting wiped out by the toxicity, which I think is probably kind of critical, right? If you're just getting killed by the toxicity, there's going to be no opportunity there. So that's kind of fortunate for the bats, and I suppose for the frogs if they're being maybe bitten in a non-lethal way initially, like maybe their toxicity is actually working quickly enough to mean that they're not sort of mortally wounded by this juvenile bat that's attempting to eat them for the first time.
Yeah, it's an interesting conundrum these bats are faced with, and I was thinking, because some mammals, they have the kind of technological know-how to extricate the non-poisonous parts from toads. But like behaviorally, like otters and stuff, they'll just like peel the bad bits off.
There's some good examples of careful eating.
But obviously bats don't have that manual dexterity, it would appear. I guess when your claws are your hands attached to a wing, that's kind of an inconvenience in terms of like using your hands for stuff. I don't really know. I haven't observed bats enough to know.
Yeah, I think it would be tricky. And they've got no bill, because that's the other way that like the hands aren't necessarily needed, because we've got bird species that will get through the toxicity, get some tasty innards.
Yeah, they don't really have the tools, the equipment. The other thing I just wanted to mention about these bats, and maybe someone who knows more about bats is listening and can tell us for sure, but There was a paper back in like the late 80s about the wart-like bumps on the faces of these bats, maybe secreting some kind of neutralizing factor from the skin of the frogs they eat. Don't know about that being true or not, but there's like a bit of a rumblings of this. And also they have some kind of weird gland underneath their jaw, which does something weird, but they're not really sure.
Interesting. I mean, that would... The fact that they can sort of get away with experimenting with some of these non-palatable toxic frogs is pretty intriguing.
Yeah. Are there bats which have the genes to protect them from toxic toads, or do we not know about that?
Yeah, that's what I'm desperately trying to think of, and I don't remember firsthand looking at any.
I don't think that it would necessarily have sprung up as like an obvious predator of invasive toads, a bat, like there, especially not these big toads.
Well, it was less about that. It was more what sort of genetic material was sort of about, right? For the study I was a part of, anyway. It's like, what do you have? Well, we've got these things. The bat stuff in, yeah. I mean, there's probably stuff around. It probably just hasn't been sequenced. Really, really intriguing. Actually, the more I think about it. I wasn't really aware that amphibians were particularly high on bats' diets anywhere, to be frank. This is kind of new to me. I mean, this is a really interesting paper because of a lot of reasons, but also that. So
yeah, it was really cool. So there we go. I think we've probably done the bats eating frogs justice. They start off as dumb little bats. Then when they get a bit older, they've learned a few things and they know which toads are toxic and which frogs are delicious. And it really tends to be, I mean, if people want to try and imagine which toads and frogs are tasty and which ones aren't, really trust your instincts. If they look sort of quite glossy and nice and moist, not too warty, and maybe delicious, meaty, they're good. But if they look a bit warty and a bit strange and a bit dodgy or brightly coloured, probably bad, right?
I'm just looking at their list of palatable versus unpalatable frogs here, and I'm thinking there's some pretty toxic brown, sort of meaty looking guy, but I suppose they're warty.
Yeah, there is. But that's
yeah, you have to follow the wardiness aspect in that. But yeah,
that's a toad. See, some of them are the same colours, like yellow. You'd think yellow would be bad, but some of the yellow ones are delicious. But then also something like Agalicnus, the old red-eyed leaf frog, that thing looks like it should be toxic.
That should be toxic.
But it's just delicious. So it's a tough one.
For a bat, anyway. Presumably. I do think that that's actually one aspect that this doesn't touch on is preference. Because, you mentioned with the Semiscus scilla, with the adults taking that one more frequently than the juveniles. And maybe it's a cool characteristic. Or maybe it's actually, that's a really tasty frog. And it takes a few goes to work out that actually it's freaking delicious, and that's where there's a preference, and it's not coming from the cool characteristics necessarily. It might be they're just super tasty. I don't know. I just like to think there's a little bit more sort of preference stuff going in here, and I would love to see some sort of work done on individual variability from bat to bat and whether there's any consistencies there. Because if you're talking about learning, like there are going to be bats that learn faster and slower and things like that. So I do think this paper really, I don't know, it gets me thinking a lot about the individuals as well as this really intriguing, broad, fringed-lipped bat finding. So it's great. And I do recommend people check out the videos too for some upside down bat awareness as they hear some calls. It's very good.
All right, well, let's move on from our bats versus frogs to a brand new species of lizard. This one's by Jia Gao, Wu, Wang, Liu, Jiang Ren, 2025. Hidden urban biodiversity. We like some urban biodiversity. New species of the genus Scincella from Chengdu, Sichuan province, southwest China, published in Animals. So, yeah, we're in southwest China, Chengdu, Sichuan province, famous for its spicy hot pots, Ben. Some of the spiciest food, arguably the spiciest food in the whole world. It'll melt your face clean off your skull.
Okay.
Yeah, it's hot. I went there and seldom been so sweaty eating meals as I was there. But as we talked about before, China, southwestern China, real hotbed of biodiversity. Normally, though, when we read these papers, they're out in the jungles, in the forests.
All the karst areas.
Or the karst areas, yes. Limestone karst, rocky outcrops that reptiles so enjoy speciating upon. But this is a different one. This one's coming from the city. We got skinks in the city. I'm sorry, why isn't it called skinks in the city? That would have been good. But
Skinks in the city.
maybe that's been done to death, to be honest. But yeah, basically they were looking around in Chengdu, which is a pretty significant urban metropolis. Chinese cities are no joke. And this one is huge. And it's actually famous for the pandas more than it's famous for the skinks. They've got the panda breeding facility there. Go there.
Oh, right.
And you'll quickly understand how utterly worthless pandas are. There's millions of them. They're not rare. There's hundreds of them. They're just in this place. And they're just gamboling around having a good time. Yeah, it is good. It is good.
Finally, it's about time.
Yeah, it's nice. It's good. There's lots of pandas. But anyway, Chengdu's not just for pandas. It's also for this new skink. And
get out of the way, pandas.
Yeah. And so they were doing a biodiversity survey in the city, in the kind of northwest of the city. And they found these populations of a genus called Scincella. And they were like, what the hell is this? They're similar to some other species, but they have unusual characteristics. And so that prompted them to do a proper rigorous analysis, looking at their morphological characters, also molecular analyses using mitochondrial and nuclear DNA. And yeah, they've
it's got nuclear thrown in too.
got enough evidence. Yeah.
Nice.
And they've got enough information to categorize it as a species. And they've given it a superb name, in my opinion, Scincella chengduensis, which just means the Scincella of Chengdu. And I mean, it's a pretty little skink.
Yes, the English name being Chengdu ground skink.
Chengdu ground skink.
Which perfectly does the job, doesn't it?
Yeah, and it's sort of like other skinks that live on the ground, I guess. It's got quite small appendages, quite small feet, a long tubular body. It just looks like your classic
non-distinct
skink.
Head.
Yeah, non-distinct head. Brown, sort of glossy back with silvery sides and then a black sort of upper side. And it's just a nice looking skink.
It is. It's just a professional looking skink.
Yeah, it looks like it does the job of eating small bugs on the ground that skinks
yes.
in charge of doing. But yeah, it's just really insane that a place as urbanized and developed and populated and with so many scientists as Chengdu is still uncovering brand new species. Yeah, I think part of the reason that Chengdu has such great biodiversity is that it's on a big hill, basically. So there's really a wide altitudinal range, which supports lots of different habitats. And yeah, there's been a gecko described recently. There's been a few amphibians. So yeah, Chengdu, still more surveys to be done and nice species. I don't think there's really a lot to say about that skink specifically, except for it's new.
Yeah.
And if you want to go Chengdu,
kind of little, we got SVLs of just shy of 4 centimeters. Kind of what it is. It's just a good quality classic skink.
Yeah. They didn't really say anything about the way it behaves or anything it does. It just exists. Cool.
Yeah. No, they do a good job of highlighting the sort of urban diversity question, which is good.
Yeah, that's definitely the hook of the paper, isn't it? Which is cool. Oh, well, that's good. Congratulations to the authors finding a new skink and giving it a superb name, Scincella chengduensis.
And if it's kind of urbany, then maybe it makes it very easy for follow-up studies from sort of local university stuff. And over the next however many years, we'll see a whole bunch of papers popping out from like master students and things that need a very convenient study reptile that can be easily commuted to.
And as little as known about because it's neat.
Yeah, so super valuable to do.
Great stuff, man. Awesome. Okay, great. So any other business? I've got one thing. Any other business? So you'll remember a few episodes ago, we were talking about the evolution of labial pits. So these pits in the lips, in the upper and lower lips of boas and pythons and vipers, but we were specifically talking about boas and pythons. And we were talking about the evolution of them all, who had them, who didn't have them.
And how they were associated with different habitats and predation styles.
Yeah. Yeah.
Choices,
tended
techniques,
to be
strategies.
It tended to be ambush foragers that used them the most. But one thing that in the trees. And in the trees. Yeah. And so one thing we neglected to mention, or we just didn't know, we were ignorant of, We said that,
completely ignorant of in my case.
and it maybe, yeah. So Aspidites, which is the genus of pythons found in Australia, Woma pythons, black-headed pythons, they actually do have a heat pit, if you will. It's just not it's not a labial one like the ones that we were talking about for other birds and pythons. They actually have a very small rostral pit, which is hidden almost beneath the rostral scale of the nose. It's like a little U shape. And Scott Iper illuminated this for us. Scott Iper, very well-known Australian herpetologist with his own podcast, which you should check out. But Scott pointed out that actually quite recently it was discovered that they have this rostral pit underneath the nose. And essentially it's actually almost hidden and can't really see out. But what they'll do is they'll actually raise their heads to like a 30-degree angle and try and get that heat sensing pit.
Allow the pit visibility.
Yeah. And Scott made the point that, these are burrowing snakes. So if they had the traditional labial pits of other pythons, it would just get filled up with sand and it would be a nightmare. It'd be constantly getting just full of crud and infected and whatever.
And how would you get that sand out again? It would be an absolute nightmare for them.
Mate, I had a fly stuck in my eye for like 4 hours on Tuesday and it fully ruined my day. I can't imagine having sand in your labial pits. That would be a nightmare.
Well, the closest experience, I think, just grab a bunch of like dirt and sand and just jam it up your nose and ears.
Yeah, bad times. Well, yeah.
And just see how that feels.
But Scott made the point that they actually do, Aspidites do have pits. I think he said he got in touch with the authors of that paper, in fact, because it was something that they seemed to maybe miss out. This is the nature of the game. Even being an expert in something, there's always more to be uncovered.
There is always more, and to treat papers as an end is, I think, giving them too much weight. I think, I don't know, my opinion on this is sort of, well, they still have a really interesting finding on the appearance and connection with different habitats to the very clearly visible pits, right?
Oh, absolutely, yeah. No, it doesn't detract from the paper.
It probably slightly weakens the identification of where things have popped up and been lost in terms of sort of heat-sensitive pits in evolutionary time. But if you want to separate those off as traits, then you can just sort of examine them separately. So I don't think it sort of undermines some of the broader strokes of that paper, but oh my gosh, do I want to see this information integrated into something fresh and more expansive?
No, I think you're right about that because it is a different pit, right? Like it's not like, oh, you've got labial pits, they're just going to evolve round to the front. Like it feels like a different structure that has to come about. The mechanism is probably very similar. I'm sure the genetic coding for infrared sensitive tissue is probably the same.
Right. That's the bit that matters, doesn't it? Is whether it's coming about via a similar mechanism. We don't know the mechanism. We're just sort of trying to infer that, right? Back in phylogenetic, back in the tree, back in evolutionary time.
You and I definitely don't know the mechanism. Yeah.
It almost comes down to this, well, if you define a trait differently, then you're going to get a different answer, and that's totally fine. It's just a question of whether you want to lump this in with the other pits or not, and I think there's a very good argument for both. I really, really want to see the one where it's been included because, I mean, this just seems like a really fascinating fossorial-specific adaptation, and I'm kind of thinking, really what this has got me thinking is, okay, so is there something to do with fossoriality that's going to pop up with this one and we've just missed it in some species? Because like you say, we were both completely ignorant of this, and that's not saying much. Like, there's so much to know out there, but it does make me wonder whether this sort of characteristic actually is more widespread than, I don't know.
It's interesting, isn't it? Because I'm just thinking about how this would translate into what the snake experiences, yeah? And imagine you're digging a hole, right? And they like use their head as a shovel. It pokes its head in. It's not going to be flicking its tongue while it's digging. It's probably not a lot. Its eyes aren't going to be a lot of use. It's underground. But if you've got a heat sensitive pit right in your nose, if your shovel head goes anywhere near something warmer than what it should be from being earth, for example, the slightly warmed buttocks of a delicious mammal, the second your face comes anywhere near that, its senses are just going to be screaming like hot, 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 hot. And so I think that's really cool. I could see that for a fossorial animal being extremely useful, like coming face to face with something, immediately just being utterly bombarded with information about its temperature where you can't really see or smell is amazing. Like, it makes perfect sense.
That is assuming, that it's entirely used to track down prey, and it might have this sort of, we've talked about it on the podcast, I think we brought it up in the episode even, of vipers choosing locations based on the thermal sort of contrast around them. And there's every possibility that it's also used in that sense to get just a richer picture of the environment surrounding them. We know thermals are important for snakes, so why not have an extra tool at your disposal to help you characterize that thermal environment?
Bang on. Cool snakes.
Fascinating. Absolutely fascinating. I really hope there's some follow-up, either with those authors or another set of authors or somebody integrating this into that examination, because that what an awesome bit. I'm amazed by them. I'm so thankful for Scott sending that in. That's so cool.
Yeah, thanks a lot, Scott. Legend. Cool. All right. Well, I think that's it pretty much, isn't it? If people want to get in touch with us, if like Scott, you have a correction, you can get in touch with us on social media, either through Facebook or through Instagram _highlights. You can let us know if you've got a correction or if you've got a question, or if you just want to get in touch. herphighlights@gmail.com is the other way you can do that. You can also find me on Instagram, Tom_E_major. And yeah, I think that's it, isn't it, Ben? All that remains to be said is thanks for listening.
Thanks for listening.